Hi everyone, this is Tony. In this video, I'll be giving a high-level overview of how we can sync YJS web apps using a Phoenix LiveView backend. Let's get started. So first off, some quick background notes. This is a follow-up to a previous video I made on building offline web apps using LiveView, Svelte, and YJS. So if you would like a little bit more context, please check out the link in the description below first. The app I showed in that video required using JavaScript on the server side in order to merge states using YJS. This works, but it's not ideal because we are running a Phoenix server, so we would have to call JavaScript using Elixir or have a separate JavaScript backend in order to run YJS on the server side. After giving it a little bit more thought, I realized that it was actually not necessary to run YJS at all on the server in order to sync the clients. In this video, I'll be giving an explanation of how all that is possible. Okay, so in this slide, I'll be setting the stage so that we have a good base to build off. On the right side right here, we have our Phoenix server with our live views, and all the live views are connected to our central database. In addition, all the live views are also connected to our pub subsystem that comes with Phoenix. On the client side right here, I have 3 clients, and each client has their own individual database. As I mentioned in the previous video, this database can either be local storage or IndexedDB. To start off simple, we're going to assume that the state is the same everywhere. So all 3 clients have a state of A in their database, and on the server, we also have the same state of A as well. Okay, so let's say the state changes on our first client here from A to A1. The first thing we're going to do is we're going to save that state up to our server. So when we go to the server, the state here will change to A1. The important thing to note here is that we're not doing a state merge. All we're doing here is simply copying the state from the client to the database. This prevents us from needing to run any YJS logic in order to merge the state on the server. Once our state is saved to the database, the next step is to publish our state to our pub subsystem, which will then broadcast it down to the live views, which will then broadcast it down to all of our clients. On the client side, this is where we actually do a state merge. So both the second client and the third client will now have their state merge with A1, which will then result in the A1 state here. So remember, the important thing here is we're actually running YJS on the client side to do a state merge, and this is not a copy of the database state to the client. Okay, so now all of our states are the same everywhere on every single client and also on the server. Of course, this is the easy path where everything is connected and online. So next up, let's look at a more complicated example where the clients are actually offline. In this slide right here, we have the same setup as before, except all of our clients are disconnected from our live views, which means they are offline. Okay, so now let's say a change is made on every single one of our clients. So the first client will go to A1, second client will be A2, and the third client will be A3. So now we have different states on every single client and a different state on the server as well. From here, let's say our first client here reconnects to our live view and is online again. The first thing that's going to happen is that it's going to make a request to the server to get the server state. In this case, it's the A state in our database. That state is going to be sent down to the first client and be merged with the client-side A1 state. In this case, because A was already the original state, when we merge the state, we still come out with the same state of A1. Once the state has been merged, the next step is we're going to save the merged state back up to the server. So the A1 state is going to be sent to the server. And here, again, we're not doing a state merge. All we're doing is we're copying the A1 state to the database. And once the A1 state is saved, The same thing is going to happen as in our previous example, where the state is going to be published to our pub subsystem, and then broadcast down to our live views, and then to the client. In this case, we only have one client connected, which is our first client up here. And since the state is already A1, when we do a merge state, it still stays the same as A1. Okay, so now the state on the first client and on the server is the same. So now let's see what happens if we disconnect the first client and reconnect with a second client. So the first thing, again, that's going to happen is we're going to request the server state, which in this case now is A1. That state will be sent back down to the client, and here we're going to do a state merge. And so the resulting state will be state A12. Once we have the state merge, the next step is to save this new merge state back up to the database. So now the database state is going to be A12, and again, this is just a copy of the client-side state. Once that state has been updated in the database, we're again going to publish it, which will then trigger the broadcast down to the live views. And in this case, we have one live view connected only. So that goes back to the second client, where the state is already A12. So everything is going to stay the same. Okay, so now let's move on. Let's say we have our third client connected, and this time we're going to keep our second client also connected as well. When the third client connects, the first thing that's going to happen is we're going to request the server state from the database. That server state is going to be sent down to the client, and here we're going to do a state merge, which will result in a state of A123. Once the state has been merged, we're going to save that state up to our server database. So now we have A123 also on the database. And again, what we're going to do is we're going to publish that state to our pub subsystem, broadcast it down, and this time we have two live views connected. So when the broadcast goes down to the third client, nothing's going to change as usual. But on our second client, we are going to do a state merge, which will result in a state of A123. So now we can see that our second client and third client have merged and converged to the same state. Okay, so we're almost there. Let's now go ahead and reconnect our first client. And the first thing that's going to happen again is we're going to request the server state from our database. That state is going to be sent down and merge with our client-side state. So now the state is the same on the first client and the server. And then again, there's going to be a request sent to the server in order to save the A123 state. The state will not change because it's already A123. But this will still trigger a publish to our pub subsystem, which will then broadcast down to all the live views, which this time is all connected. And then they all receive the same state, but this time all the states are already all the same, so nothing will change. Okay, so as we can see, all of our states on every single one of our clients and also on the server is now in sync. And again, the important thing is we never had to do any state merging on the server. Every single time a client reconnects, we basically have to do two things. First off is we have to request the current state on the server, merge it with our client. So that's step number one. And step number two is once we have that merged state, we send that merged state as a copy back up to the server. And if we do that every single time we reconnect, we're able to keep the states in sync among all of our clients without ever needing to do merging on the server. So to recap, there are two cases we need to handle in order to keep our client states in sync. The first case is when the client is already connected. In this case, the first thing we do is we update the state locally. Then we save a copy of that new local state up to the server. And then lastly, we broadcast that state out to all the connected clients. The second case is when the client is not connected. In this case, we still update the state locally first, and then we wait until the client is reconnected to the server. When it's reconnected, we first request the server state, and then we merge that server state with our local state. Then we save a copy of the new merged local state to the server. And then lastly, we broadcast that state out to all the connected clients. All right, so just some closing thoughts before I wrap things up. In the app that I built, and also in the slides that I just showed, every single time we make a change, we are sharing the entire app state between the client and the server. This works, and it's a very simple mental model, but it's definitely not the most efficient. As you can probably imagine, if we have an app with a very big and complex state, we may eventually run into performance issues. One possible way to solve this is to only send updates rather than the entire app state. This is possible with YJS. If you're interested, I left a link here to the YJS documentation where this is covered. For my app, I decided to keep things as is for now. Sharing the entire app state keeps things simple. However, I may update it in the future if I find that I need to improve performance. And that's it. Again, this was a very high-level overview of everything, so if you would like to see more details, please feel free to check out the source code. It's available on GitHub. Additionally, if you would like to see everything I just discussed in a live demo, please check out the app on fly.io. And lastly, if you have any questions for me about anything, please feel free to reach out. My contact information can be found at tonydang.blog. Thanks for watching.